Hey there! Welcome to this video where we will explore how you can hot reload and test your Lambda functions locally using localstack. I'm Harsh, and in this tutorial I will show you how to continuously update and apply changes to your Lambda function without requiring any manual commands or instruction. Generally, while you're trying to deploy and test your Lambda function, you have to either use a .zip file archive or you have to upload a container image to Amazon ECR. However, iterating over these functions could be a slow process. Every time you make a change, you have to redeploy before testing or debugging. This could slow down your progress and increase your cloud cost. But with localstack, you can rapidly iterate without the need for manual redeployments. Localstack offers a feature called as Lambda Hot Reloading that allows you to directly mount your source code into a Lambda function. This means that you can test your changes instantly without repetitive redeployments. In this video, I will demonstrate how you can achieve Lambda hot reloading using a node runtime with a TypeScript Lambda. However, you can follow the same approach for any Lambda runtime that you prefer to use. I will also show you how to integrate it with an infrastructure as code provider, such as Terraform in this case, for seamless development and testing loop. So without further ado, let's jump into the code. Before we set up a hot reloading configuration, let us dissect the anatomy of our Lambda function. We have already created a file named index.ts which contains our TypeScript function code. Let us take a look into the code right now. We have a Lambda function handler which, when invoked, runs the method and returns a response. In this case, it returns an HTTP status code and a simple JSON message which signifies a hello world right here. Nothing fancy yet. Now to actually deploy this, we need to transpile the TypeScript code to JavaScript. If you're using serverless application model or cloud development kit, this process is going to be easy. But in case of AWS CLI, which we are going to use, we will be going with using ESBuild. Let us install the dependencies that we have already specified in the package.json file. So let us go ahead and type in npm install. And this will install all the dependencies that we actually need to run this particular Lambda function. Now, if you navigate to the package.json file, you will get to see that we have configured a build script. Now, this build script builds your Lambda function and transpiles it into JavaScript because it can be used with our Node.js runtime. And on top of that, it uses a watch flag to basically look out for changes and rebuild the TypeScript Lambda to provide you a complete and automated feedback loop. Let's actually do this and run the build script through npm. Once we run this build script, you will notice that we now have a dist directory and it contains our transpiled JavaScript code. Now we can actually go ahead and run our local stack container to create a new Lambda function with a hot reloading configuration. You can run the local stack container using the local stack CLI or a Docker setup or a Docker Compose setup. If you have not installed local stack before, check out the documentation on the description below. I will be using the localstack CLI to start my localstack container. Let us type localstack start and give this a run. Localstack will take a few seconds to start up, and once done, you will get to see that the container is available now. To do a pretty quick test to see if all the services are available, I will try to access the health endpoint of my running localstack container. You can go ahead and you can curl this particular endpoint, and you can get to see that all of the services on localstack are available right now, which includes EC2, Elasticsearch, Lambda, OpenSearch, and more of that. Cool. It seems our localstack container is ready. To use the AWS CLI to create a Lambda function, we will use the AWS local script. It is a wrapper script provided by localstack itself that redirects all your AWS CLI calls to a local stack container instead. For an easy setup, I have the following command that I can simply copy paste here. Let us explore the significance of each of these flags and their configuration right over here. At first, we are using AWS local lambda create function to create a Lambda function using the AWS CLI itself. We have configured our function name to be hot reload lambda, which should act as our Lambda function, but you can change it to whatever name you want to prefer. Next, we have configured the runtime to be Node.js 16.x. You can use a different runtime if you are creating your Lambda function in Python or Ruby or something else. We have also specified an IAM role ARN that the Lambda function will simply assume. Please note that you don't exactly need to create a real IAM role, since localstack essentially mocks them out for you. Here, we have provided the S3 bucket name and the S3 key where our code is particularly located. In this case, the code is located in the hot reload bucket, and the key is set to the current working directory followed by the dist folder name. This is where the real magic is happening, because in this case, the hot reload is a magic variable which is configured to deploy the Lambda from an S3 bucket, and the S3 key simply points to the path of the directory where your Lambda function is basically residing in. In this case, it is pointing to our current directory with the dist folder which contains the transpiled JavaScript code. Let us actually run this now, and you can actually get to see that your local stack logs are firing up, and now your Lambda function has been created pretty much upon your local machine. You can actually go ahead and check the Lambda functions on your local machine using the Lambda list functions API. So over here, I can get to see that my Lambda function has been created with the hot reloading configuration that I can take for a run right now. So now that we have created a Lambda function, we can actually go ahead and invoke the Lambda function on our local machine with the invoke API. So let us copy paste this command right over here. And we have specified a very simple payload, which is action and test. And this will spit out all of the output inside the output.txt file. If you want to check what's happening in the background, you can actually go to your local stack logs, and you can get to see that the logs are pretty much firing up right now. Cool. So it seems that our invocation has been successful. We'll get to see the status code, and we get to see that the executed version is latest. And we also have a new output.txt file. Let us open this, and over here, you will get to see the JSON with the status code and the body actually returned. So we get to see that the status code is 200, just like how we specified in our Lambda function, and the message is specified to the hello world. Cool. So why should we not go ahead and make a change to our Lambda function itself? Let's actually do that. We'll go to index.ts file, and maybe we can change this hello world to hello local stack. Sounds cool, yeah? So now that we will save this file, you can get to see that our entire TypeScript code has been transpiled into JavaScript once again. And from the local stack side of things, nothing actually has changed, because what we have already done is that we have mounted our local directory into the Lambda function. Let's actually give this a run. You can go back to this previous terminal, and you can invoke the Lambda function once again. This should take really short time. And yes, we get to see that the status code is 200 once again. And now that we go to the output.txt file, we'll get to see that the message is actually hello local stack right now. Isn't it cool? Yeah. So over here, you can get to see that you can pretty much change your Lambda functions on your local machine without having to update them or anything of that. And local stack will immediately reflect all of the changes to your Lambda function in real time. With a configuration like this, it simply makes it easy for you to test and debug your Lambda functions on a pretty steady basis. And we can also get to see how we can configure the same thing using an infrastructure as code provider like Terraform. To set up Lambda hot reloading with Terraform, I have already created a Terraform configuration in my main.tf file. I have also started a fresh local stack instance so that I can test my changes readily. In my Terraform configuration, I have configured the AWS provider and the region where the resources are to be deployed to. Apart from this, an AWS IAM role is defined with an assume role policy that basically allows the Lambda service to assume this role. Finally, an AWS Lambda function has been created, and it specifies the function name the IAM role to be associated with, apart from the handler of the function. The function's code is located in the same magic S3 bucket known as the hot reload, and the key has been set to being the absolute path of the dist folder of the root directory. Let us take it for a run with the tf local script. The tf local wrapper script is provided by localstack, and it allows you to redirect all of your AWS API calls being made using Terraform from AWS to a local stack container instead. Under the hood, we are using an override mechanism to make this possible. So let us run this by stating tf local init, and it performs similarly to the Terraform init command itself. So let us press enter. It will initialize the backend and the provider plugins, and it will set up the environment that is necessary for us to deploy all of these resources to the local stack container. So the Terraform has now been successfully initialized. We can actually use the same tf local script along with the apply command to actually create the resources on our local stack container. If you're using Terraform with local stack, you don't need to worry about any dangling resources that should be deleted, because you can just shut down your local stack instance and all of the resources created on your local machine would be automatically deleted. So now we can press yes. Terraform will perform these actions as we have stated in our configuration. And this will take a couple of seconds for Terraform to create the Lambda function. But once done, we can get to see that the Lambda function has been created and the Amazon resource name is particularly available here. I can use the Lambda list functions API to basically get to see that my Lambda function has been created, and now I can take it for a run to check if my hot reloading is actually available or not. I can use the same command that I have copy pasted before. And this should take just a few seconds, and you can actually see your local stack container firing up right now. And once done, our invoke API is successful, and we can get to see the status code and the executed version. I can navigate to my output.txt file, and I can get to see that it has a hello local stack message right now. So let us go ahead to our index.ts file and maybe change this back to hello world. As soon as we save this particular file, we can invoke the Lambda function once again. And this should again take a couple of seconds. And if you go back to the output.txt, you can get to see that the message has gone back to hello world, as we have stated in our index.ts file over here. So you can see that the Lambda function is now deployed. It is now being invoked, and the hot reloading is actually working out. And this whole exercise readily shows us of how easy it is for you to set up hot reloading for your Lambda functions with your favorite infrastructure as code provider. In this example, I showcased you how to do it using Terraform, but you can follow a similar setup using CDK or SAM or whatever ISE tool that you're using. All that you need to set is to go back to your ISE infrastructure configuration and just set the magic variable for your S3 bucket and the S3 key, and the rest of the things will be taken care by local stack itself. And that is basically all that I have to show you. In this video, you learned all about localstack's Lambda hot reloading feature and how you can configure it on your machine. If you'd like to go one step further and configure breakpoints in your Lambda function, we have a remote debugging feature that allows you to exactly perform that in VS Code or IntelliJ. Remote debugging combines the concept of local code mounting with a debug server or package like debug. If you're interested to learn more about locally developing and testing your Lambda functions on your machine, check out localstack's documentation and join our Slack community right in the description below. And if you liked the video, don't forget to like and subscribe. Peace.